Hello, welcome to the second part of the 8.3 notes where we are going to be showing that a quadrilateral is a parallelogram. So in this chapter we're going to be doing this kind of a lot for when we learn about more quadrilaterals, because so far you've only learned about parallelograms. We're going to have to figure out, based on the coordinates of the vertices, what kind of quadrilateral it is. So we're going to start off simply with parallelograms and how to prove that, the 4 different ways. So I'm going to go ahead and graph it, although you really don't have to graph these in order to prove them, and in the future we're not going to graph them, and on quizzes and tests we're not going to graph them. But for now, let's do that just so you can have a visual of what we're doing. That's a little bit too thick right there. Let me make this a little bit thinner. Alright, so I'm going to go ahead and graph it. Let's go ahead and do that. 0, so that's right there. 2, 0 is where point A is, and by letter and by where it is. So 2, 0. 3, 4 is B. C is at -2, +6. And then D is at -3, +2. All right, it is never, ever, ever going to be enough to say, oh, it looks like a parallelogram, so it is. Obviously, that's going to give you no points when your teacher is grading it, so please don't do that. Let's draw it in, and like I said, we're not always going to graph it anyway. Sorry for my sloppy graph. All right, so the directions for this one says if both pairs of opposite sides are parallel, then it is a parallelogram. So the way that I'm going to show that it is a parallelogram is I'm going to prove that both pairs of opposite sides are parallel. So how do we show parallelity in a coordinate plane? Well, slopes. If two lines or line segments have the same slope, then they are parallel. So what I'm going to do, and you have to be very careful when you do this to label everything. I always tell my students, if I can't tell what you're doing, I'm not even going to grade it. It's your job to make it clear to me. Just like when I teach you how to do this, I'm being very clear. Right here, I'm going to find the slope of CB. Then I anticipate, based on the picture, that it's going to be parallel to AD. So I always like to put those two guys next to each other. Then I'm going to find the slope of the other two sides, so CD, and then also the slope of AB. All right, in case anybody has forgotten, slope formula is and always has been y2 minus y1 over x2 minus x1. So if I want to find the slope of CB, I'm going to take a y value of C. I started with 6. I'm going to subtract from B. I'm going to subtract the y value 4. I could have started with the C value of y, or I could have started with the B value of y. It doesn't make a difference. But because I started with 6 over here in C, I have to start with -2 from C and then -3. So I get 2 over -5. Doesn't tell me anything. All right, let's do the same thing for AD. 2 minus 0 over -3 minus 2 is 2 over -5. Remember that 2 over -5 is the same thing as -2 over +5 is the same thing if there was a negative in front. So these are parallel. Okay, now let's do the same thing for CD. So 6 minus 2 over -2 minus -3, it's going to end up being a +3. We get 4, and then the slope of AB, we got 4 minus 0 over 3 minus 2, and that is 4. If I went through slope kind of quick, there's a reason for that. You've been doing slope for a very long time, so I just assume that you know how to do that. All right, so I would say since both pairs of opposite sides are parallel, A, B, C, D is a parallelogram. Whoops, that should say B. Parallelogram. You do have to write a sentence explaining, especially later we are going to be proving more specific parallelograms, so you do have to explain why it is what you think it is. All right, let's take a look at number 2 over here. It says if the diagonals bisect each other, then it is a parallelogram. So that means this one we are going to prove by showing that the diagonals bisect each other. So let's go ahead and draw it. A is at -3, 0. It's gross. B is at -2, -4, 1, 2, 3, 4, -2. Actually, I'm going to put this on the other side because it looks like this parallelogram is going to be going to the left. C is at -7, so 4, 5, 6, 7, -6. 1, 2, 3, 4, 5, 6. And finally, D is at -8, so it's off the charts, and then over here, kind of. Not the best job drawing, but that's okay, because the picture is literally not important at all. Okay, and in fact, the way I drew it absolutely does not look like a parallelogram whatsoever, but that's okay. All right, so what I'm going to be showing is that the diagonals, this diagonal AC and diagonal BD, bisect each other. So what that would mean is this segment would be congruent to this one, and then this one to that one. All right, so if this is true, that the diagonals bisect each other, this dot that I'm drawing here in the middle, this dot should be what's called the midpoint, because it splits a segment into 2 equal pieces. So let's refresh midpoint, because that one's one that kids forget a lot. You take the x's, you add them, you divide by 2. You take your y values, you add them together, and you divide by 2. It's like calculating an average. The middle of something is calculating the average if it's 2 things or 3 things or whatever. But because we're adding 2 values, we're going to divide by 2. So again, I'm going to be very clear in my labeling. I'm going to find the midpoint of, let's see, AC. And then I want to find the midpoint of the other diagonal, which is BD. Those 2 segments. Okay, so let's find the midpoint of AC first. I take the x's, -3 plus -7, divide by 2. Then I take the y values of A and C, 0 plus -6, divide by 2. And I get -5, because -3 plus -7 is -10, divided by 2 is -5, and then -3. Okay, so that's the midpoint of AC. Now I'm going to do the same thing for BD. -2 plus -8 divided by 2, and -6 plus -2 divided by 2. Just kidding. Hold on. That should not be a -6, that should be -4. So let me erase that. Sorry about that. -4. Okay. So -5, comma, -3. And I knew that I made a mistake, because if I added those, I wouldn't have gotten -3 when I divided by 2. So I knew something was wrong. And I went back and looked, and I'm like, oh, I used the wrong order pair. All right, so here we're going to say, since the midpoints of both diagonals is the same point, or the midpoint of each diagonal is the same, A, B, C, D is a parallelogram. Okay, you are going to get points for writing a sentence explanation for why it is what it is. All right, so I don't know if you like that way. I think that way is really easy. However, proving a parallelogram using midpoints is going to be very, very, very useless in future sections when you're going to be trying to decide, is it a rectangle, is it a rhombus, is it a square? This way doesn't help you at all, whereas finding the slopes or finding what we're going to do on the next page is going to help you further narrow down what kind of specific shape you have. Okay, so this way, although it's easy, is going to be, you're going to be wasting your time if you do this in the following sections, in the future sections of this chapter. So don't do it. And actually, I should say do it if you're asked to do it, but otherwise don't. If it's an open-ended question where you could do it using any method that you want, this one is going to be a waste of time. Okay, number 3 says, if both pairs of opposite sides are congruent, then it is a parallelogram. Okay, so again, let's graph it. -4, +1. 1, 2, 3, 4 is A. Sorry, 1, 2, 3, 4. -4, +1. That's A. B is at +4, -4. 1, 2, 3, 4. Here's B. C is at 7, 0, so C. And then -1, +5 is point D. All right. Let's draw our parallelogram. All right, in a coordinate plane, hopefully you all realize that the way to show that segments are congruent is by using the distance formula. So here is distance formula just generically. X, you subtract the x's, square that answer, then you're going to add the difference between the y's and square that answer. All right, so again, based on my picture, I see that I'm going to anticipate that the length of AB is going to be, or should be, if it is a parallelogram, the same as the length of DC. And then AD should be the same length as BC. All right, so if you're one of my students, you know that I don't write out every single step of the distance formula because I think that's just a waste of time, kind of. I just do part of it in my head. So the way I do it in my head is I ask myself, okay, 4 and -4, how far apart are those two numbers? How many steps would it take me to get from 4 to -4? It would be 8 steps, and then I square it. And that's the same thing if I did -4 minus 4 and then square that answer. Plus, now I do the same thing, 1 and -4. How far apart are those? 5 steps, and then I square it, giving me the square root of 64 plus 25 is the square root of 89. And I don't care if that simplifies or not, I'm just going to leave that as my answer. All right, now I do the same thing for CD. From 7 to -1, how many total steps would that be? If I picture a number line, it's 8, and then I square it. Or again, plug it in. 7 minus -1. That's how I got 8. That's how far apart they are. And then plus 0 plus, minus 5, or how far apart are 0 and 5? It's 5 squares, 5 steps apart. So I get 8 squared plus 5 squared gives me the square root of 89. It's the same as what I just had, 64 plus 25. All right, now AD. So if I look at A and D, let me erase all these circles that I made because I don't want to miss any negative signs. All right, so from A to D, my x values, my A value for A, the x value is -4 to -1. How many steps would that be? 3 steps total. Plus from 1 to 5, how many steps would that be? 4 steps total. This is going to equal the square root of 9 plus 16. That's the square root of 25, which simplifies to be 5. All right, now last one for BC. From 4 to 7, this is what I'm looking at, the x values from 4 to 7. How far apart are those two numbers? They're 3 units apart, so 3 squared plus from -4 to 0. How many steps would that be? 4 squared. And again, if you don't like what I'm doing, don't do it that way. Just plug in the numbers into distance formula. Okay, so these have the same length. And then the next two have the same length. So I have proven that it is a parallelogram. Again, notice with my work, I labeled everything. Imagine if I did it and I just said, okay, just find this length, this length, this length, and put random numbers all over the page. I would think that most people would be lost and be like, what is this lady doing? So do the same on any kind of quiz, assessment, or your classwork. Make sure that you are showing your work, labeling it clearly, not having just like a mess of numbers all over your page. All right, so we are ready to say why this is a parallelogram. I would say since both pairs of opposite sides are congruent, and I could be more exact and say which ones. So like I could say AB is congruent to DC and AD is congruent to BC if I wanted to. ABCD is a parallelogram. And the way I'm writing this isn't set in stone, and your teachers may write it slightly different. Like I could say ABCD is a parallelogram because, and then say both pairs of opposite sides are congruent, or whatever, however your teachers want that explained. All right, last one here says if one pair of opposite sides is both parallel and congruent, then it is a parallelogram. So let's draw this one out. Again, let's label it 0, -6. It's going to be 1, 2, 3, 4, 5, 6. Here's where A is. B is at 4, comma, -5. So right there, that's B. C is 6, comma, 3. Right there. And then D is at 2, 2. Right there. I don't want to say, or I don't want to say it looks like a parallelogram, so therefore it is. I have to go and show it. All right, so one pair of sides is both parallel. So to show parallelity, remember it's slopes. Congruency is distance formula. Okay, so I'm going to pick, and it doesn't matter which pair of opposite sides. I could go DC and AB or AD and CB. Either one is fine. So I could just pick one. I'm going to do AB and DC. I don't know why. I just chose to do that. So now I have to do each of these cases. I have to find the slope and distance formula. Sorry, that should be a 2 for each of these. So the first thing I'm going to do is the slope of AB. All right. So -5 minus -6 over 4 minus 0. This is going to equal 1/4. And now I'm going to find the length of AB. And so that's going to be the distance formula. So from A to B, x's are 4 units apart, so 4 squared, plus the y's are 1 unit apart, so 1 squared. So it's going to be the square root of 16 plus 1, square root of 17. All right, now let's do the same thing, but we have to do it for the side that's opposite of AB. So I'm going to do DC. So slope of DC is equal to 3 minus 2 over 6 minus 2. So I get 1/4. So notice this and this. Wow, that's gross. This and this are parallel. All right, AB is parallel to DC, and then I'm going to find the length of DC. So that is going to be 6 to 2, the distance between 6 and 2. My x values is 4 squared, plus the distance between 3 and 2. How far apart those are is 1 squared, so I get the square root of 17. So notice that these two are congruent. Okay, so my explanation. Since, and I'm going to write this a little bit better, AB is parallel to DC and AB is congruent to DC, ABCD is a parallelogram. Okay, so those are the different ways. Notice that we did not use any formulas or any way to prove it using angles. We can't do that in a coordinate plane. We can't show that opposite angles are congruent or consecutive angles are supplementary. It's just not something that we can show. So instead we have to rely on them being parallel and them being congruent. Of all of these ways to do it, to prove that a quadrilateral is a parallelogram, the most popular that you should get used to doing, and if you have a choice, use either the first way, which is showing both pairs of opposite sides are parallel, or the third way, which is showing that both pairs of opposite sides are congruent, because it will help you in the future. Okay, thank you for watching. Have a great day.